So before we jump to machine learning, do you guys remember this particular, the Venn diagram? Do you remember this Venn diagram? We guys have studied. You guys have studied in the very first session of AI, if you do remember, in the first session. Yes, Chirag. Yes, Chirag. Yes, Karan. So yes, Vansh, Sahil. Okay, Chaudhary Zeel. Yes, yes, absolutely, all of you. So this is the reason why I have, why I have kept, this particular Venn diagram again in this particular slide. Uh, and the reason is like just to make you guys aware exactly how we are one by one, like session by session, we are deep diving into the different stuff. So in the very first session, like if I just talk about the core of your field, that is computer science, and then you guys have studied something about AI, and then now you will be understanding something about machine learning as well. You guys already know about machine learning because in the very first session, I do remember I told you, some basic fundamentals of machine learning, some basic types of machine learning. But of course, guys, in today's session and in day after tomorrow's session, we'll be having, unsupervised learning, particularly a proper a single day dedicated to the unsupervised learning. Sorry, supervised learning, and then on 23rd, unsupervised learning. So all of this stuff we will be covering, guys. So this is how we will work. Okay. So now, so computer science, AI, ML, and then self-supervised machine learning, unsupervised, supervised, deep learning, all this stuff we'll be covering today. And you will get to know exactly what does LLM stands in this. LLM, where is LLM here? There is no LLM, right? Acha, okay, where does LLM stand in this? So in deep learning, LLM stands in deep learning. Okay. LLM stands in deep learning. Why? Because LLM uses neural networks. Okay, multi-level perceptron, and okay, yes, sign. Okay, yes, Chirag. Okay, so all this thing we will cover. So now let's jump to machine learning. What exactly the machine learning is, right? So if you guys know, right? If you guys know, so now the machine learning is something what that is related to algorithms, mainly algorithms. So before machine learning, uh, do you guys, okay, can you guys tell me something about the automation? Can you tell me like something about automation? Like, is automation all about AI, or can we automate something without AI as well? What is your point of view in this? Can we automate without as well? How? How, Vishwajit? How, Chirag? How? IoT, okay. Without AI, we can do it with Selenium, okay. Condition from the model of ML. No, I'm saying without ML. Okay, so ML is also, see, guys, this is the reason why uh, I've shown this particular slide to you. That machine learning comes under AI only. Okay, programming, exactly. Programming. So the automation is nothing but the automation is nothing but you know it's a simple, I generally call it a spoon feeding means like you are explicitly you are typing, you are explicitly you are mentioning what to do, when to do. If you face this, then do this. If you face this, then do this. If this particular test case comes, do this. If you face this error, do this. If you have this issue, do this. So this is this is how we will, we used to automate the things in programming. But why AI? But why AI? And it's a very basic question that generally a recruiter used to ask. What is the difference between AI and automation? So automation can be done by both AI and the programming. But when it comes to AI, when it comes to machine learning, it's all about it's all about not programming explicitly. Yes, Ashish. Okay. So this is the thing. Yes, yes. If you want any particular outcome and we use certain line of code to do that. Yes. So this is the reason why we have machine learning. So when we actually train someone, what is the difference between training and uh, you know because just difference between training and just giving the source of information. What is the difference? So imagine there is a guy, there is a kid. Okay, so there is a kid, and now I'm about to ask him or her two or three questions. Now, there are two options in front of him. Either he should learn the answer, how to answer those three or four questions. He should learn. Okay, he doesn't know the questions. Okay, he doesn't know the questions. Or the second thing is he should have a particular, uh, the book of 100 or 200 questions. And when a person is asking him, any of the questions, so he can just refer to that PDF or that book. So first thing is he should learn, and second thing is he should carry a proper, document for this. So without carrying a document, what if we make him learn so that automatically it will be able to answer those three questions, not only those three, but those three questions will be completely new. And this is the power of machine learning. When you train a machine learning with the help of, when you train something, with the help, when you train a machine using machine learning, and when you train a machine, I should not use the word train, when you automate the task using programming. In programming, it will only handle the stuff that you have mentioned in programming. But in machine learning, you can ask him to read the thing that was not even there in the data set. You can ask him to solve that question as well. And yes, it will be able to answer those questions just like you guys. Okay. I can ask you the definition of machine learning in different way, right? But you will be able to answer because you are human, you learn, right? And this is the definition of machine learning, guys. Machine learning allows computer to learn and make decisions without being explicitly programmed. It involves feeding data into algorithms to identify patterns and make predictions on new data. So it is as simple as this. So we basically give the data to algorithms. Okay. When we say model, this model means algorithm. This model means algorithm. That's it. So the model means algorithm, and we give stuff to that algorithm to identify patterns. Okay, and then we give actually the new questions, actually to give new stuff. Okay, new data, new questions to answer, to predict, to cluster. Okay, to do some dimensionality reduction. Sir, what is clustering? What is dimensionality reduction? What is it? Don't worry, we'll cover. Okay, everything we'll cover. Today in today's class, you will be having a really nice stuff. I'm damn sure. Okay, so now let's understand this particular example that you can see on the screen. So in the first example, what exactly is happening? See, this man has trained this particular robot. Okay, this and said this is the dinosaur. Robot said okay, and now this is also a dinosaur. Robot said all right, and so is this. This is also a dinosaur. Again, okay. Hey, where are you, man? Where are you? Again, now, which is this animal? Stupid human didn't tell me about something like this. Okay, let me guess. It's a dinosaur. So, can you see exactly how it is working? So, first, human trained him with three examples. First example is this. He said, okay. Again, second example is this. Again, he said, ki this is also a dinosaur. Okay, all right. And then again, so is this. Okay, now he disappeared. And now again, there is a picture in front of him. And now it is guessing. So this guessing is learning. Okay. In even in exams also, without actually looking into the encyclopedia or book, you guys can actually answer those questions. So what exactly you are doing? You are guessing it, right? And you and the person who is getting 99% means he is 99% correct in his guessing, his or her guessings. If somebody is getting 85 marks, means it is he is 85% good in guessing. So this is how you actually work. You guess the things, right? Let me guess. And did you guys notice something? Each time whenever this man is giving some answers, this is dinosaur, this adjusting weights is written. Adjusting weights. Adjusting weights. See, again, adjusting weights. All right, adjusting weights. This all right means adjusting weights. Again, adjusting weights. So this, what is this weights? What are these weights? Okay. So now to understand the learning of machine, can you see this particular next graph? Okay. This, black and, red clusters, data points basically. So can you guys see like how this particular line, this 45-degree or 30-degree or this line is actually, trying to these, oh, sorry. Actually, what is this doing? This is actually trying to go to the pattern that it can see. Means, okay, let me simplify this. So these two lines, can you see these two lines? One line is going above, okay, upwards, and one line is going downwards. Downwards, there is a cluster of black data points, and in upwards there is complete separate cluster of red data points. And now, one by one, slowly. Okay, guys, can you guys see my camera, right? You guys can see the camera, right? You guys can see my face, right? If I'm not wrong, you guys can see my face, right? Yeah. No? Okay, why? So, just a second. Okay, okay. Uh, Thank God I literally asked this question. Now, perfect. Yes. So, what exactly this is? So, what exactly this is? So, this is something, let me now tell you. Yeah, perfect. So, somebody asked one question. So you are drawing or writing in another app. We cannot see. No. I was not writing. On the screen only, can you see these two graphs? Two basically animations, right? So I was just talking about these. Okay. Yeah. Yeah. Yeah, Chirag? Works. Chalo. Now let's continue. So can you guys see this this line? There are two lines. Okay. There are two lines. One is going upwards, one is going downwards. And this is not going like this. Shut. No, it is like this, right? Yes, something like this. Something like this. So after, each second it is moving second by second. So this second by second is nothing but learning weights. Why this is not jumping directly? Hey, this from this to this. And what are these lines? These lines are the patterns understood by machine. So machine is directly learning straight line. Machine is learning what? By default. By default is straight line. By default is straight line. But now, one by one, it is adjusted like this and it is adjusted like this. See? So initially they were like this, and now it has adjusted like this, and it is adjusted like this. Right? So this is how they learn the pattern. So this line, this 45-degree, approximately 45-degree line is line of machine. How where machine is learning. And now one by one it is shifting towards the data, shifting towards the data. Okay, right? Good, good. So why do we need machine learning? Why do we need machine learning? So to answer this question, to answer this question, so there are lot of stuff that is going on, and the simple thing is to avoid unnecessary coding, to save time. If you guys have noticed, if you guys have noticed till now, most of you might be of 20, 21 years old, approximately. Okay. So if you guys have noticed, each and every scientific invention, okay, each and every invention is totally, you know, is based on time only, right? More or less, the stuff is related to time only. Each and every invention is trying to reduce the time as much as possible, as significantly as possible. Okay. So do this machine learning. So machine learning is also basically, without being programmed. And to write program, if you guys have done some programming, like just to train up normal, just to create a normal interface, just to create a normal interface, you'll require, 200, 300 lines of code, right? In traditional programming. But in machine learning, like I'll be, like we'll go through that. You will hardly require 40 to 50 lines. Yes, to be honest, like to train it properly, you would require 200, 300 or more than that. But to get that task done with the help of programming, you would require, trust me guys, 10,000 lines of code. If you want to achieve that stuff with the help of the traditional programming, you will require 10,000 lines of code, and that part we can do with machine learning in just few hundred lines of code. That's it. Okay, so this is why we need machine learning. So in traditional programming requires precise instruction and struggles to handle complex tasks such as understanding images or language. Yes, just imagine guys, let's suppose prediction. Let's suppose prediction. You know, if you guys have explicitly program everything for all kind of questions, how will you train and related to images? How will you train it related to the human interaction? How will you train it? In that case, you need machine learning. You cannot do this stuff with the help of programming. Even, uh, yeah, Janish, it's a request for everyone. Like right now, please don't put the non-technical questions. Okay, let's take the non-technical questions after this session. Okay, I'll be with you. I'll be answering all the questions. Me and Adarsh ji, we will be answering your questions. Okay, now please focus on the technical part that we are discussing. Okay, okay, Janish. Okay. So it can't efficiently process large amount of data. Yes, right? In programming, you cannot, efficiently process, even though you try some, really nice techniques, really nice methods to really nice functions that has really less time, space-time complexity. Even then, it won't be as efficient as machine learning. This is the reason why we use machine learning. And then machine learning solves this example by learning from examples, problems by learning from examples, and make prediction without fixed rules. Means in machine learning, you no need to define a specific rule. Okay? You don't need to define a specific rule. You can just control it. And how to control it? This is called hyperparameter tuning. Can anybody tell me what is hyperparameter tuning? To control machine learning, the learning of a machine, we use hyperparameter tuning. Can anybody tell me what is hyperparameter or hyperparameter tuning? Something related to hyperparameter, if you guys know. To enhance performance and accuracy of model. Mhm. To control the effect of particular Nidhi, okay, Darshan is saying to enhance performance and accuracy of model. Okay. Nidhi is saying to control the effect of particular feature. To control the effect of particular feature? Um, Not exactly. Nirmal is saying to find the optimal settings that minimize loss and maximize accuracy. Yes. Okay. Meet is saying training data with every algorithm to find best ones. Okay. Adjust parameters like learning rate, batch size, etc. to fit perfectly on data. Okay. Yes. Who said this? Parth. Yes, Parth. Okay. And Chirag, select best values. Okay. Chaudhary is saying for configuration of external. Okay. Jayanandan is saying task performance experience and hyperparameters. Okay. Chirag again. Yuvraj. It's like neuron in machine learning, which have some weightage to result. No. Hyperparameter tuning is not the weightage. Hyperparameter is related to weightage, but it is not weightage. To maximize the accuracy. Yes. Yes, to maximize the accuracy, Goswami, okay. Darshan, Nakshi, okay, almost similar. Ashish, okay, almost similar answer. Learning to the peak with effective, okay. Vivek is saying training model to maximize accuracy, perfect. Yeah, pattern prediction, okay, okay. I got your point. I got your point. It's good. So mainly these are the points that we try to understand to why we need machine learning because it's a complex, solver. Okay, we can literally solve a complex problems, even though we have given a really simple problems. But after learning it multiple times, it can actually solve multiple complex problems. And then scalable data. Okay, scalable data means you can process the high amount of data with the help of machine learning, but you cannot do it as simply it with programming. And then again, automation. But yes, automation is a part of programming as well. But here, automation is, with less time complexity, with less, resources. You can with the huge data you can automate. So this automation will be definitely better than the programming. Okay, and then it is adaptive. Adaptive means like if you have trained something for today, it won't be relevant for after 6 months. Then you need to train it again. Then again train. Means you can just make it see the same model, you can just make it adaptive after based on your real-time data. So the model will be same, the algorithm will be same, but you can just make it adaptive. So this is the reason why we need machine learning. Then let's jump to next part. So how machine learns. Okay. So this is the flow that is there, how machine learns. The machine learns by identifying patterns in data and improving its ability to perform specific tasks without being explicitly programmed for every scenario, as I told you. Okay. So how machine learns basically? How machine learns? So, okay. Now let me tell you something. Okay. First, so there are different type of machine learning. Okay. So, but broadly, how machine learns is it basically understand the patterns. If I just take you to this, if I just take you to this slide, this what exactly it is doing? It is trying to match the flow. But do you think it is actually matching the flow? Do you think it is actually matching the flow, guys? Do you think it is actually matching the flow? Both the lines? Explain the hyperparameter tuning. Yeah, yeah. Okay. Hyperparameter tuning is Asif. Uh, like there are so many, points. You can just take it as a steering wheel. Okay. So just imagine you have a machine. Okay. You have a machine and you have 10 different steering wheels. So one steering is related to the power, one steering is related to the speed, one steering, not a button. steering. One steering related to uh, like uh, like what? Like how these two will perform to get the best output from these two steerings, and one steering to other. It's like a steering. See, if you will, so the best task, the most important, crucial task for any machine learning engineer is to get the best set, the best configuration of steering. So, okay. So just imagine the best accuracy would be like to shift this first steering to 60%, second steering to 70%, third steering to 10%, fourth steering to 50%. And just like this, alag alag means different steering has different values, and then after getting the best, you know the best hyperparameters values, you will train your model with the best accuracy. This is basically hyperparameter tuning. I know I have just given you the just uh, talking example, but we'll learn more about this in upcoming slides. Okay, sure. So now, okay, I hope you got the point. So now can you see this? So, do you think, guys, that this particular line that you can see, fluorescence X, fluorescence Y, if you can see, like it is trying to understand the pattern, but do you think the line is relevant to the stuff? Okay, just look into the red dots. Can you just look into the red dots, everyone? Can you just look into the red dots? Do you think this single line, it is able to learn the red dots? There are so many dots that are not on exactly on line. There are so many dots that are not exactly on line. So even it is trying to understand the pattern. Some points are here, some points are here, some points are exactly on line, some points are here, some points are here, some points are this far, some points are, this far. So there are different points, different distance. So almost every point, there are only few points that are exactly online. Only few points that are exactly online, but most of the points they are not exactly online, right? Most of the points, they are not exactly online. So how, this works then? How this works? So this works based on the data. Okay. These points that you can see here, these points that you can see here is are data points. Okay. These are the data points. These are the basically the training examples. Okay. And then it is trying to learn it with the help of some mathematical algorithms. So the first part is data input. The second part is algorithms. The third part is training. Okay. And fourth is feedback. Means we are training, but then we will, try to ask, na, hey, how much you have trained? How much you have trained? Right? Okay. Just imagine. First I gave you 100 examples. Okay. First I solved 100 examples in front of you. You are also solving this with me. Okay. But then I'll ask, hey, and so any doubts? And then you'll say, yes, sir, one doubt. Okay, sir, two doubts. Okay, sir, three doubts. So after, understanding 100 questions, you had three doubts. Means you are saying, sir, I have understood 97% perfectly. Only I have three doubts. Please clear that. Okay. So sorry. It's good then. It's good. But now, so now this was the feedback. Hey, I gave you 100 questions. How many you have understood? Sir, 97 I have understood. Aman, 97 I have understood. It's good then. 97 you understood. But then what else? Like now, is it good? Now, is it good? So you think, yeah, it is good. It is good. So do you want me to improve it? Yeah, 97 is good. Okay, no need to improve it. Let's test it. But what if you get 50 doubts? What if you get 50 doubts? In 100 examples, you are getting 50 doubts. Means only 50% you have understood, in other 50% you have doubts. So now it's my responsibility that I'll actually try to improve your, accuracy. Means I'll try to improve as much as possible. Okay. Yeah. Sir, what is explicitly programming? I can see in every definitions. Okay, explicitly programming means like uh okay, so there is a robot. Okay, there is a robot on a uh okay, so there is a robot on a single road, and now we have actually programmed to walk on that road. Now, what if you see a pole in front of that robot? What you will do? No worries, sir. I'll write. If you see a pole, go right, then go straight. Means turn right, then turn left, and go straight. I'll write this. Turn right, turn left, go straight. I'll write this. Okay. But what if again it feels like this? You will again say, oh, simple, sir. Again, turn right, turn left, go straight. But don't you think, like, after doing this 2 to 3 times, it will go out of the road? Okay, sir. So I'll write to after 2 or 3 times, go left, go right, then straight. It will come to this side. So again and again, you are trying to deal with each and everything. What if there are 5 poles? Then what if there are 5 poles? One, two, three, four, five. Then your this particular logic will not work because you have programmed it like go right, go left, it will work. No, after going right and after going left, again there is a pole. Then what to do? Again going right, again going left, again there is a pole. So again and again, you need to actually tackle all the problems, whatever can be faced by that robot. But with machine learning, and see, you have to tackle means you have to write it code. You have to program it. But in machine learning, you don't need to program it. Okay, you have to train it. And once you will train it, you can just simply just put it on the road and just forget. It will do the work. It will automatically understand where to go, when to go. Okay. So this is how machine learning works. And this is what exactly the explicitly program. Okay. I hope you have understood, Asif. Chalo. So this is how machine learns. Okay. They take the input, they understand it, they train it, then they give the feedback. Okay, I have understood 50%. Then what we do? We try to increase the accuracy. We try to increase the accuracy. We try to give them the feedback. Hey, you are at 50% good. Try to improve. Try to improve. Hey, sir, like I'm unable to improve. I tried my best. I can only get 60%. Before this, I was getting 50%. You asked me to practice those questions 100 times. I practiced 100 times, and now I'm getting 60%. But still, that this is not enough. You won't accept it. Yeah, I won't accept it. Then what I have to do? Okay. So this guy is learning, this guy is practicing too hard. But still, that accuracy is not improving. Means I have to do something from my side. I have to do something from my side. Okay. Then I'll do some hyperparameter tuning. Okay. Then I'll just give you some different types of questions. Then I'll give you some different types of tricks. Then I'll give you how to, how to multiply quickly. If your calculation is not good, I'll put some effort in with your calculations. If we are not good with the basic concept, I'll teach you some basic concepts. If you're not good with, the writing, I'll ask you to write properly so that even if you know the answer, you won't be able to write. Then write it actually. So this is how I'll give you the feedback and I'll just train you. And then after, practicing, you are also already practicing 100 times, 200 times, 300 times, but you are not getting more than 60%. But now after doing this hyperparameter tuning, after training with different stuff, you will be able to get 90%, 85%, 93%. And this is how machine learning works. And now, then we test it. And after testing, we actually see how it is working on test data. Sir, we got the accuracy, right? 97% after hyperparameter tuning. Yes, but we got the accuracy on the training data. We got the accuracy on the training data. Now we will give some data. Now we will give some data that is completely new to test it, how it will work with real-time problems. And then I'll actually, calculate how much accuracy it is getting. Okay. And then my actual outcome should be similar to training data. Means in training data, if it was 93%, in test data, it should be around 90-92%. It should be around 90-92%. Okay. So this is how we train machine learning models. Any doubts till now? Guys, can you give me any doubts? Sahil is saying it's learned from Centroid. It's learned from Centroid. But like how you can say this? Like where you can see the Centroid here? Where can you see this Centroid here? Where is the Centroid here? Right? It is not understanding the Centroid. Centroid is a particular point, not a line, Sahil. Okay. Yeah, it you can say that it might be looking forward to centroid so that it should pass from that. But just imagine there is a centroid here. Imagine there is a centroid here. So without changing this, I can do this. So if actual pattern is this, so if I'm also doing this, then your logic will work. Even if I'm doing this, your logic will work. So passing through a centroid is not actually the purpose. Okay. Even the correct line is this. And if this is the centroid, then this is passing from the centroid. Good. But so this, so is this, right? So is this. So this point is same, right? So actually passing from the centroid is not a, actual target. Okay, Sahil? I hope you understood. Yeah. Yeah. So Parth is saying line is fitting so that overall distance between all the data may get less. Point. Good, Parth. This is what exactly it is. This is the reason why, you will be able to get the machine learning really quickly. Good one, Parth. So how the clusters are formed according to the data or conditions, instructions. So clustering is, we are about to discuss that. Okay, Asif? Just hold on. Okay. Thank you for asking this question. We are just about to discuss. Okay, Asif. I hope you've understood the basic fundamental of machine learning. The basic fundamental of machine learning. Okay? Sure. Let's move forward. Sure. This is how machine learning works. Sure. Now, machine learning life cycle. Now, machine learning life cycle. Okay. So now, how machine learning life cycle works? So the machine learning life cycle is all about, gathering the data, matlab means data collection. Then you do EDA, right? You do EDA, exploratory data analysis, means data preparation. And then you do data wrangling. What is data wrangling? Means feature engineering. So what is feature engineering? I don't know. Aman. So we'll discuss feature engineering in detail. Okay. We'll discuss feature engineering in detail. Okay. In few slides. Okay. Okay. It's a crucial part, guys. It's a crucial part before machine learning. Okay. Okay, then after data wrangling, we do analyze the data. That whether we have properly we have created the features or not, properly we have analyzed the features or not. Are there any duplicates? Are there any is there any null value left? Is there any outliers? So in data preparation, generally we used to check the null values. We used to check the duplicates, but when it comes to the outliers, generally people used to get those outliers stuff after data wrangling. Because in data wrangling, in feature engineering, basically, you can just use this term interchangeably, up to you. So in feature engineering, what we do is we actually do a lot of stuff. We used to create new features. We used to understand the features that are already existing. And if you are creating a new feature, means again you need to do this data preparation. New features are coming, right? New columns are coming, new columns are generated. Means again you need to understand the pattern, right? How it is working. And then after this, gathering data, data preparation, data wrangling of feature engineering, and then analyze the data, then you train the model. And guys, one more thing. In feature engineering and data analysis and analyzing data, you actually scale the data also, right? You also scale the data. Okay. Can anybody tell me what is scaling the data? This word is not there. This word is not shown in this particular, the animation. But can you tell me what exactly, uh, this, what is it? It's all about. Can you guys tell me? Creating, Darshan is saying creating new data from old data patterns. Oh, that is data, that is feature creation, no? Feature extraction. Improve the data accuracy. Mm-hmm. HP is saying, okay, what else? Okay, never mind. So basically, okay, so do you guys know the answer? Scaling means convert data point to particular range. Why? Sir, I'm asking, if you guys don't know what I'm asking is, I'm asking about scaling. There's a word scaling. Scaling the data. Why do we scale the data? Can you guys tell me why do we scale the data? Into similar range or scale so that no feature dominates others because of larger numbers. Yes, Sahil, for accurate answer. Guys, try to answer by yourself, okay? Please don't copy it from Google. Please don't copy it from somewhere else. Okay? Try to answer. Like you know the answer, right? Try to answer by yourself. Okay? Okay. So this is there are some columns with lower range data, 1 to 10. There are some columns with high range data. So, exactly. So basic stuff. Basic stuff. What is basic stuff? So just imagine, just imagine. Um, okay. See, after all this is machine. After all this is computer. After all this is nothing but numbers. How machine learning, how any machine learns. It learns on numbers. Even it doesn't understand these letters and all. This is for us, not for the computer. So how computer learns? So computer learns with the help of numbers. So whenever you decide anything, see, machine learning is also about the decision, right? AI also decides something now. So how does AI decides? So before taking any decision, what do? We actually decide the priority. We actually decide the priority and we decide the priority. Okay. So from 0 to 10, 9 priority I should give this. 8.5 I should give this. 2.5 I should give this. 3.9 I should give this. 4.2 I should give this. From 0 to 10. So this is how I decide my priority. Okay. For different things. And then on the basis of that, I take decision. This is what we do generally. Machine learning also does do the same. Yes, exactly, Parth. This machine, this algorithm, this mathematical algorithm, this model actually give more priority to higher range values. Okay, sir, then what is the problem? The problem is, just imagine, okay, if I want to see the pattern, okay, if I want to see the pattern, if someone is senior than me, he might be getting more salary chances, normal chances. He's more experienced, he's more aged, so he's getting more salary. Done. No issues. It's okay. It's a normal thing. Okay. My salary is something, his salary is more than this. Good. Okay. But just imagine, I'm not talking about two different people, two different data points. I am talking about the same data point. So just imagine how, like, I am not only having salary, I am also having a age. I am also having age, right? So just imagine my age is 25 and my salary is something in lakhs. Okay. So my model will think, okay, this age column is not that important. This salary column is more important. But this is not correct. Age is also important. Salary is also important. Both columns are important, right? If I am if I am having one designation in 5 years and the other person who is having 15 years, okay, but still having only one designation more than me, means I am growing better, right? So age is also important. But how model will work? It will consider age. Hey, age 25, 85, oh, not 85, 85 is too much. 65, 55, 43, 39, something like this, right? Okay. So it will, as compared to the salary that is in lakhs, it will consider it as nothing. And this is where the scaling comes. What scaling will do? What scaling will do? What scaling will do? Scaling will convert this age to 0 and 1. Okay. And this salary also to 0 and 1. And now both are on same scale. And this is where scaling comes. I hope you got the point. Right? I hope you're getting it. Okay, Chirag is saying example of age. I think you give that example. Age group of 20 to 22. If there is any 1 to 30 age, then no, no. See, no, Chirag. The problem is not with the same column. That is actually important, right? Okay, okay, okay. So if I'm talking about age, if I'm talking about your age and my age, my designation, your designation, that is okay. Totally different data points, right? Okay. So if I my age is 30, your age is 22, okay. So this is how model will run, right? Your age, basis of your designation, basis of your salary. My age, basis of my designation, basis of my salary, right? This is how it will run. But the problem is one column is about my age and one column is about my salary. Okay. So now it will give less priority to my age, more priority to my salary. And this is the issue. I want to treat both the columns equally. Okay. And this is where scaling comes. It is not the part of, it is not there in the, uh, this animation, but it is a part of analyzing the data. It is a part of data wrangling, basically. Okay. Chalo. And then we train the data. And then we train a model. Okay. Then we test the model. And after testing with good accuracy, we deploy the model. Hope you are getting the point. Okay. We deploy the model. And then, okay. Hey, sir, but in the animation, we can see after deploying the model, again, it is going to gathering data. Why it is like that? Uh, can you tell me? Like I told you, it is adaptive. Do you remember this? Do you remember this slide? Yeah, here. The last point was adaptive. That after some time, we have to again make it learn to understand the latest patterns, to understand the latest real-time scenario. Just imagine there is a hype of colors right now. Why? There's a hype of plastic stuff. Why? Because of Holi in India. But after a few months, in October, November, December, there will be the hype of some crackers, right? So to understand the hype, different hypes, nobody used to wear new clothes on Holi. Everybody used to wear new clothes on Diwali. So if you want to put sale on clothes, you need to put sale on clothes not on Holi, but on Diwali, right? So this is how, This is the reason why after deployment, again you need to gather the data. Again you need to do the data preparation. Again you need to data wrangling. And again analyze the data. Again train the model. Then again test the model. Then again deploy it. And after some time, again gather the data. Same system. This is the reason this animation is like, in circle. Okay, so Chaudhary is asking, but how do we know what column is important or not? Okay, so this is not up to us, Chaudhary. Okay, actually, Manish, this is not our stuff. Let machine decide. Let machine decide it. Which column is more important? Okay, okay. And if you want to understand like which column is more important, which column is actually significantly impacting it. So, do you guys know hypothesis testing? Manish, do you know hypothesis testing? Do you know hypothesis testing? You are asking like how to know which column is important, which column is not. So, if you want to understand it by yourself, you need to learn hypothesis testing. Okay, you can just Google it. Okay, after this session. Okay, uh, okay, and if you want to machine to decide, then machine will decide based on the patterns. Which column is important, which column is not. Okay, nice, good. Chalo. So now let's talk about the types of machine learning. I hope you got the point, Manish. Manish Kumar Chaudhary. Okay, chalo. So now types of machine learning. Again, you know it: supervised, unsupervised, and reinforcement. Okay. Can you guys tell me if you do remember, like we have already discussed like a few of them in the very first session. Can anybody tell me like what is supervised, unsupervised reinforcement? And then if you know supervised, if you guys can tell me something about classification, regression, clustering, dimension reduction, associate rule, you know. If you don't know associate rule learning, it's okay. It's okay. If you know it, it's good. Supervise me learning with labels. Okay. What else? Unsupervised reinforcement, classification, regression, clustering, dimension reduction. Unsupervised means Chirag is saying learning without labels. Okay. Prashant is saying supervised, we have predefined data. Hmm. Okay. Chirag is saying enforcement means reward and penalty. Okay. Vishwajit, uh, okay, with label supervised, without label unsupervised, learning using environment, enforcement. ठीक है. Goswami, regression on numerical data, classification on categorical data. Okay. The Teerth is again same. Label, unlabel, penalty, reward. Tejas is saying try and error. Okay. Fusion, reinforcement, model learning from reward. Okay. Okay. Now points is clear about supervised learning. Answer is clear. Unsupervised learning, again, answer is clear. Reinforcement learning, answer is clear. Supervised learning, learning from labeled data. Unsupervised learning, learning from unlabeled data. And then reinforcement learning, penalty, reward. Now tell me something about classification, regression, clustering, dimensionality reduction, and all. Okay, Tirth is saying collection of same type of data. Okay, what else? Okay. So Vishwajit's association is based on if then. Okay. Manas is saying dimension reduction extracting only important information which are not correlated. Okay. Not exactly correct, Manas. Prashant is saying classification, we classify data based on predefined classes. Chali. Okay. Now classification is predict for predicting label and regression for predicting value. Okay. So basically, now we have understood classification and regression. Now tell me something about clustering. Okay, Vishwajit is saying clustering means grouping. Okay. Okay, tell me something about clustering, dimensionality reduction. Tell me something about clustering and dimensionality reduction. Everyone. Clustering means grouping. Regression means regression is done. Uh, okay. Darshan is saying clustering means learning from multiple groups in the data. Learning from multiple groups means what? Like how it will learn? Like this is what I exactly want to know. Like in supervised, I have understood. Like it will first give the examples, then it will ask like how it is, looks like, and then you will give the answer. But how unsupervised learning clustering is learned? Clustering means chunk of similarity. Somewhere it is correct, Chirag. Good one. Shlok is saying clustering is grouping a similar type of data characteristic. Sahil is saying, what is Sahil is saying? Clustering means group of similar data group. Okay. Anuj is saying in clustering we identify on the basis of majority of data points. Ashwin, clustering means grouping a label data based on similarity. Chinal, clustering means create a cluster of different groups of things. Dimensionality reduction involves removing unnecessary features. ठीक है. Darshan means we can divide particular feature into sub group. Okay. ठीक है. ठीक. Okay. So Pujan is somewhere different. Pujan is saying group of similar data which have centroids. Okay. You are going somewhere to K-means clustering. So now Manas is saying makes an centroid based on data. Chalo. So the crux is in front of us. Okay. So kudos, guys. Almost everyone is correct about all the definitions. Almost like with 93%, 97% accuracy, 95% accuracy average. Okay. Only few answers were, somewhere around the actual answer, but most of the answers were correct. It's good, guys. It's good. So now last answer, let me take of Sujal. Clustering means organize data into group, which such way it has the highest number of members containing the same attribute rather than other clusters. Good. Yes. But the interesting part is, guys, these answers are theoretical, right? Oh, of course, sir. You asked us theoretically only, right? Yeah, of course, theoretically only. But when it comes to the understanding, theory works for humans, but never works for machine learning. So everything is algorithmic, and therefore we need to understand the algorithm, right? So now let's take some examples. Okay, so first of all, we'll one by one looking into classification, regression, clustering, dimensionality reduction, what exactly it is. Okay, few of the people were really good, correct about the dimensionality reduction as well. Let me tell you something about all this stuff. Okay, one by one. So now supervised learning. So this is how supervised learning looks like. Okay, this is how supervised learning looks like. So can you see? So supervised learning is simply, you know, it's a type of machine learning in which model is trained on label data where the input is paired with the correct output labels. Means this is simple. Like you are actually giving the examples. Means answer of this question is this. Answer of this question is this. Answer of this question is this. Now, what is the answer? Do you remember this kind of scenario in the very first slide? See, Okay. So what exactly it is doing? First, it is giving the examples. Hey, this is dinosaur. See this? Okay. Adjusting weights. Again, this is also a dinosaur. Again, good. Adjusting weights. Again, this is also a dinosaur. Again, adjusting weights. And then suddenly he disappeared. Oh, that dude disappeared. Okay. Wow, look at that animal. So now let me guess. Which animal is this? Dinosaur? Yes, absolutely correct. So this is the really brilliant example of supervised learning. Okay. So here also what we do, first we train this with the label data with labels, then we try to test it. Okay. And test it means not with the new examples. First we actually check the accuracy of the training data only. I told you, right? First we check the accuracy of training data means first I need to ask now whether you have understood this example correctly or not. I have given you 100 examples, and by yourself you are saying before test only, sir, I have not understood 50 questions. That means you have only understood 50%. Means I need to make it at least 93% examples, 90, 95, 99%, so that when you will give the test, at least your accuracy will be somewhere 95 or 90. I need to train you till 99%. Right? Then your actual in your Excel exams, you will be somewhere above 90. Okay, so first I need to train it, then I will evaluate you. And then again, I'll improve you. How will I improve you? With the help of hyperparameter tuning, with the help of more data, and some other stuff. Okay, and then I'll test it. And then I'll test it, and just imagine, then I'll test you. And if you are getting accuracy somewhere around, that is significant, then that is good. If you're not getting accuracy that is significant, that is not good. And we need to again check with the hyperparameters. We need to check with uh, the different tools through which we can get the better accuracy. There are some regularization method as well. Okay, regularization method as well, because these are somewhere, directly or indirectly mathematics. So let's take it afterwards. Okay. ठीक है. Sure. So this was the basic example of supervised learning. Sure. So now how it works. So first we get the clean data. Okay. Clean data set. Then we split it into training data and test data. Okay. Then we, with the help of training data, we train the model. Then we score it. See, it is scoring the trained model. Okay. And then we evaluate it. Okay. And then after evaluating the trained data, we test it and then we deploy it. So this is exactly what we do. Okay. Okay. So this is the main, the process all about. This is the main process. Okay. Good. Now the types of supervised machine learning. First is regression. Second is classification. Okay. So if you guys, can you guys tell me some example related to regression and classification? Some examples. Some real life examples. Some real life examples of regression and classification. Hmm? Okay, so regression is house price prediction. Okay, house price prediction, predicting tumor classification, student score. Guys, why are you all of you giving the same example of house price prediction? Is it in your curriculum? Does that belongs to your curriculum? Ah, hmm. That is why I'm getting the similar. What else? Can you give me any other apart from this? Okay. Can you give me something about a classification? Predict customer segmentation. Okay. Nice. Numerical value like weather, temperature. Yeah. Yeah, it is considered. Yes, Zeel. Okay, Tejas, Poojan Patel, business sale regression. Hmm. Chaudhary, okay, Manish, mock exam dashboard. Mock exam dashboard. No. How it is related to regression or classification, Manish? Goswami, disease analysis. Disease analysis. But it is analysis, right? It is not machine learning. Goswami. Yuvraj, identifying product category in all classification. Yes. Correct. Good one. Good one. Good one. I can see really nice answers. Chali. So now let's study some examples related to machine learning. Okay. Some examples related to machine learning. So the examples related to machine learnings are, first stuff for regression. Okay. And we'll actually try to understand with the help of uh, similar examples so that you will understand it. And I have already given this example in the first session, if you do remember. So let me correct. Yeah, almost you are correct, yeah. Trisha, Uttam, yes. Image recognition, Uttam, image recognition, regression or classification. What exactly it is? Acha, chalo. So types of supervised learning. So regression is output should be numerical. Classification is output should be categorical. Okay? Output should be categorical. Can you tell me uh, the algorithm that you use in regression? Can you tell me the algorithm that you use in regression? Can you tell me the algorithm that you use in regression? Linear regression? Logistic regression? Guys, in regression problem. Guys. This is where, I wanted to ask you this question. This is the reason. Why linear? What is the difference between linear regression and logistic regression, guys? Yeah, decision tree linear. So now let us try to take the basic. So what is linear regression or what is logistic regression? What is the difference? Where do we use linear and where do we use logistic? Vishwajit is saying y is equal to a plus bx. What is it? It is for linear or classification. Means sorry, it is for logistic regression or linear regression. Regression, not algorithm. There are type of regression, not algorithm. Yeah, you can say that. Yes, Prashant. The algorithm, the basic crux is same. Yeah, Prashant. The basic crux is same, but the output is different. Yes, this is what I wanted till now. Exactly for this question. Yuvraj is correct. Linear regression is for giving you some numerical output. But logistic regression is to give you some classification, means categorical output. Okay. If the means at the end of the output, at the end of at the end of the final stuff for regression, it will be a numerical value. Yes, Sahil. Yes, Vishwajit. But for logistic regression, it will be a categorical. Okay, categorical means it will be like A, B, C, D. Okay, it will be a categorical. Okay. It will be basically 0 to 1. Okay. Now, twist, guys, twist. Twist is, then why both are called regression? If one is giving us numerical output, regression is something numerical, right? Right? This is the reason, right? In regression problem, the output should be numerical. In classification, it should be labeled. But why a logistic is regression? Then why logistic is also a regression? Logistic regression is solving problems classification. Well, why logistic actually a regression? Linear is regression, we know, because it is giving us numerical value. I know. Good. But why logistic also a regression? Without Googling, guys. Just give me the normal answer. If you don't know, it's okay. If you don't know, say don't know. It's okay. But I want a proper answer. In linear regression, we have multiple dependent variables. Goswami, it converts output to 0 and 1. Converts output to 0 and 1. Converts output to 0 and 1. Hmm. Both work similar to predict the line. Mm-hmm. Mm-hmm. Goswami is somewhere correct. It converts output to 0 and 1. Somewhere it is correct. But not the exact reason. Means, yeah, means the output is numerical. So you can say that. After all, Parth is saying because it predict labels in the form of probability. But in linear regression, it doesn't predict something in probability. In linear regression, it actually gives the output in numerical. But numerical output cannot be a probability. It can be a probability, but most of the time that it can be any number. Your salary, your age, uh, okay, your temperature, whatever. Any number can be there in linear regression. But in logistic regression, it's definitely a probability, 0 and 1. But why? This is the reason why this is regression. If it is actually giving categorical output, if it is giving a categorical output, even if we say, see guys, even if it is giving 0 or 1, actually it is categorical, right? 0 can be cat, 1 can be dog, right? Both are relationship between put it on, put it on. No, no, Sahil. Now tell me. Now let me tell you guys. The answer is both have the similar architecture to give you the output. Output is different. One is giving you the numerical output, one is giving you the categorical output. Completely fine. But actually, but actually, the basic fundamental, the basic architecture of linear regression, logistic regression is same. The basic architecture of linear regression, logistic regression is absolutely same. Both works on weights, both works on, a simple line. Okay. Yes, now Shesh is correct. Linear regression predicts continuous numerical values using a straight line, while logistic regression predicts categorical using a straight line. Okay, again using a straight line. Okay, so this is the basic reason why both are called regression. Somewhere Goswami was actually correct. Somewhere Goswami was actually correct because it doesn't matter. Linear regression is giving the numerical output, logistic regression is giving the categorical output. But even if you will see the output of logistic regression, that is also in numerical only, 0 or 1. That is also numerical, right? So yes, that is also a kind of answer. But the actual answer that you need to mention is the architecture behind both the is same. Both the algorithm is same. Okay? This is the reason why both are called regression. Both actually try to solve the weights. Both actually try to learn the weights. Both actually give the weights to each and every feature, priority to each and every features, and then it learns the pattern and then it gives you the output. Are you understanding? Hope you've understood the actually the reason, mathematical reason behind calling a regression. Okay. Sure. So now like, I was on the examples. So the really nice example is, let me predict, let me guess what will be the temperature tomorrow. Okay. So in Fahrenheit, it's 84 degree Fahrenheit. Okay, 84 degree Fahrenheit. So now this was the problem for regression, numerical value. But now, on the basis of this 84 degree Fahrenheit, I want to classify whether this 84 degree Fahrenheit is cold or hot. So I again used another model. I gave this 84 degree and I asked whether this is called hot or cold. And it said it's hot, right? And this is one example. Second example is, like, there's a house prices in town. So house prices in town means, like, oh, this is the reason why you are giving house price, is it? Okay. So house prices in town. So let's suppose it is 200k dollars, 208,000 dollars of house price. Now, this was a regression problem. I am predicting what will be the uh, like price of houses in my town next year. This is I'm predicting. But now I want to classify whether that price will be affordable or expensive. Whether that will be affordable or expensive. So this is classification. Guys, guys, can you give me a simple answer now? In both these examples, giving the numerical output as a temperature 84 degree Fahrenheit, as a house value $208,000, that is okay. But don't you think this prediction of this classification, whether this 84 degree is hot or cold, $208,000 is expensive or affordable? So don't you think it just need one line of code? If it is above 60 degree, then it is hot. If it is below 60, then it is cold. If it is above $200,000, it will be expensive. If it is below, then if it is below than that, it is affordable. Can we say this? Can we say this classification solution? Simple, right? In my example, I predicted a numerical number in the form of temperature, in the form of house price next year. Now, I want to classify it, whether it is hot or cold, 84 degrees Celsius, and whether it is affordable or expensive, $208,000. So, do you think like it just require a single line of code? If the temperature is above 60 degree Fahrenheit, it is hot. If it is below, it is cold. If it is above $208,000, if it is, oh sorry, if it is above, let's say again any number, if it is above $200,000, it is affordable. Oh sorry, expensive. If it is below than that, it is affordable. Why? If yes, why? If no, why? It can be applied in real-time data. If yes, then why? It depends on surrounding. Surrounding is what? Where is machine learning here? In regression problem, I can directly can see machine learning. But now I want to simply classify this 84 degrees Celsius to hot and cold. I need a simple line of code, right? If this, then this. If this, then this. Else this. Simple. It's just logic. Yes, you know. Sahil is saying atmosphere, environment. I'm not getting the answer. Can you please elaborate? Yes, Deep is saying yes, technically, but it depends on many other aspects like what are the requirements and what inputs are taking and from which basis. Hmm. Okay. Deep is somewhere correct. Sahil is also somewhere correct. You guys know the answer. That is really nice here. You are not actually pointing out the thing, but definitely you know the answer. I got the point. You know the answer. You are actually on the right path. Sahil is also on the right path. Deep is also on the right path. Okay. Uh, who else? Yeah, I got some really nice answer from Prashant. So right now we can say that this is particular example. In this particular example, okay. But when we have large data set, then we are about having multiple possibilities. So directly not possible. We must train data from all possibility. Now the question answer is really good. There will be multiple possibility for the large data set. Good, good, appreciate it. But this logic will work for that also, right? See, for me, if you will ask me to touch 100 degree Celsius of boiling water, okay, it will be too hot. It will be too hot for me. It will be too hot for you, for both of us, right? So this logic will work, na? This logic will work. If it is above 80 degrees Celsius, it is hot. It is if it is below 80 degree, it is cold. It will work for all the people, the whole data set. Where is the machine learning, guys? So do you want me to give the answer or do you want to search and come? Do you want me to give the answer? Do you want to search and come? Guys, okay. Search and come. Chalo. Good. Thank you, Shesh. Okay, only one person is interested. Depend on different types of object. Sahil is saying, okay. Depends on geographical area. Some cities it can be hot and some cities it can be cold. Hmm. Somewhere path is correct. Yes. I told you, you know the answer. Okay? You know the answer. In the second half, just find the answer and come. Okay? Not an issue. I am here completely for you. And please do, let me know when you are ready with the answer. Okay? If I just, forgot it, just remind me. Darshan is that the classification will be variable like India for 35 to 40 degrees is common, but in Germany it will be too much. Yeah. Good, Darshan. Repeat question. Uh, Chirag. Repeat question means like in 84 degrees Celsius, we have predicted something. So it is completely machine learning. In $208,000 house price, we are predicting for next year. Good. But how come we can say classification as prediction? Because we are simply classifying, uh, we can simply classify with the one code, right? Why we need machine learning? Below 80 plus 80 degrees, 80 degree Fahrenheit, cold. Above 80 degree, hot. Below 200 and $200,000, affordable. Above $200,000, expensive. See, we have to predict for future. Then we have to analyze past data, and Jinal is saying this. And in the data, we have to predict in future. That is too affordable, expensive. Somewhere correct. Somewhere correct. Search and come, guys. Chalo. Now let's talk about the unsupervised learning. Please do remind me the question, okay? Please do remind me the question. Chalo. So unsupervised learning. Now, what is unsupervised learning? Unsupervised learning is a type of machine learning, okay, that actually, uh, uh, works without the help of labeled responses, okay, without the help of labeled responses. So how with the help of this animation, can you guys tell me how basically it learns? What it is learning? Like I have not given any examples. So what exactly it is learning? Answer is right in front of you, everyone. Okay. Again, people are giving me the answer for the previous question. I request that we'll take that question in the second half again. Okay. Sahil, I appreciate your answer. You are almost there. I don't want to read it, but I just want you to, search it more. Okay. Deep Parmar also, same for yours. Okay. Now let's focus on the present slide. Okay. Deep. Okay. It finds similar patterns and cluster them together. Okay. Aradhana is saying to classify data. Darshan is saying it is learning and similarity in objects. Okay. Okay. So Harshurya, Ishita Harshurya is saying group similar data. Okay. Deeparma. Okay, sure. Okay. Jinal, unlabeled data are labeled in training phase and clustered them. No, no, Jinal. There is no labeled data. Not in training, not in testing, nothing. No labeled. Training without labeled data. Uh, yes, Dhruv, correct. Yes. So most of you are correct. Most of you are correct. So the answer is simple. Understand the pattern. Simple. You guys are almost correct. Okay, almost means you are guys are correct. Simple. Understand the pattern. If see in the owl, in the category of owl, there are three basically animals that you can see here. Okay, one is owl, one is fox, and one is I think squirrel. So the tail of squirrel is little bit longer than uh, fox, fox or dog, whatever. It is different than fox, and owl is not even having tail. So can you just pick this particular pattern? Okay. So owl is not having tail. So one column will be tail. Owl, no. Uh, Fox, yes. Squirrel, yes. And now, next column, next column, length of tail. Owl, zero. Fox, uh, you know, medium, medium. Yeah, small. Okay, small tail. Squirrel, medium tail, medium length tail. Categorical, right? Categorical. Now, color. Owl, yellow green, yellowish green. Okay. Fox, orange, yellow orange. Squirrel, white brown. Third attribute. Three attribute done. First was of whether it has tail or not. Second, length of tail. Third, color. Now you can pick other patterns as well. And now, after understanding these attributes, it will basically create the groups. Simple. It will create the groups. Okay. And this, this is the example of clustering. But unsupervised learning, as you can see here, it is not only about clustering. It is also about dimensionality reduction. It is also about associate rule learning. Okay, yeah, feather, Sahil, yeah, Sahil, absolutely correct. Yeah, Viren is saying unsupervised learning is a type of machine learning where model find hidden patterns and structures and unlabeled data without being given the correct outputs. Yes, clustering means group similar items. Yes, Viren. So Raj Patel is saying like tries to learn the different pattern and bifurcate them like that of X clustering algorithms. Okay. Sahil, pattern and data similarity. Okay, sure. Good. It's good, guys. You guys learn so fast, by the way. I must appreciate this. So, so did you guys studied all these things before this, or it is the first time you are understanding these concepts? No, Prashant, they are not same. Okay, okay, nice. It's good. It's good. Okay, okay, nice then. So in that case, okay, got it, Manish, got it, Chesh. So types of machine learning. So first is you can see the clustering only. Okay. Can you give me the if you guys know all these things, can you tell me in the left graph, in the left graph, there are three clusters, right? Can you, if you can see the this animation, can you just tell me which type of clustering algorithm example it is and how and how and how? K-means clustering? How? What happens in K-means clustering? Partitioning clustering? How? Give me the answer how. What is K-means clustering? You know the answer, right? You guys have studied in semester 7. People are saying we have subject centroid based. Okay. But, but, okay. So if you can see my class, if you can you see my cursor, everyone? Can you see my cursor? Yes, right? Just give me a second, Just give me a second. Let me just raise this, just increase the length of this. Just a second. Meanwhile, you can answer if you want to answer anything. Meanwhile, you can answer. I'm just increasing the point. Let's Okay. Okay. So let me reshare screen. Hmm. Yeah. So now you'll be able to see my cursor as well. So if you guys can see the cursor, so where is my, can you see the cursor? Can you see this point where my cursor is present? Okay. If you can see the point where my cursor is present, this can also be a centroid. Everyone, this can also be a centroid. No? Why? Why this cannot be a centroid of these two cluster of this one cluster? Can I consider this one cluster with this centroid? Why? Why not? If yes, then why? If no, then why? No, it's an outlier. How you decide outlier in K-means clustering? Will you consider this outlier? Okay, Nirmal. It's good. Yes. Good, good, good. So some of you are giving really nice answers. So yes, Euclidean distance. Okay. K nearest neighbors. Okay, but it doesn't require exactly the k nearest neighbors. You can simply put Euclidean distance. and just put the average distance. If it is greater than that, it won't be there, the part of that cluster. Okay. Though it has some disadvantages, but this is how it is. Chalo. Now, now in the right graph, you can see there are four clusters. Okay. There are four clusters. So initially there were uh, so many clusters, but eventually after learning, it has created four clusters. Okay. See, eventually there were so many. There were around uh, 4 5 clusters, but now it has exactly four clusters. Right. This is how clustering works. Okay. And then this is dimensionality reduction. Okay. This is dimensionality reduction. Okay. So dimensionality reduction means, what is dimensionality reduction? Can you tell me? What is dimensionality reduction? Can you guys tell me? Converting features from 3D to 2D. This is dimensionality. Why do we need dimensionality reduction? If you guys can tell me. We are about to close the first half. Okay. Right after 7 minutes, we'll close it and then we'll rejoin it at exactly 1. Okay. Till then, if you can just tell me what exactly the dimensionality reduction is, that would be great. Uh, so, okay. So, Nirmal is saying like 3D to 2D. Tejas is saying reducing number of input features. Number of input features. Why do we need to reduce the number of input features? Why do we reduce the why do we need to reduce the dimension? And first tell me what a dimension. See, why I'm asking these questions, because you told me that you have studied a few things. So that's why just I'm asking. So okay, if you don't know the answer, it's completely fine. I'll definitely tell you. Okay, because dimensionality reduction, you guys generally study in mathematics as well. Okay, dimensions and all in 3D geometry and all. So that's why I'm asking. Okay, if you don't know the answer, it's completely fine. It's good, no issues. So Manas Patel, accepting only important features which are not correlated. Okay, what is the issue with correlated features then? It means reducing the number of features while keeping the important information. Viren is saying this. Okay. Kush is saying we remove irrelevant input parameters to reduce complexity of model and less computation power required. Okay. Reduce number of columns without losing information. To reduce noise from data. Noise from data. Okay. Reducing the irrelevant columns to analyze in more efficient way. Okay. We use dimensionality reduction to remove necessary features. Okay. Most of the people are saying one thing. Is that reducing the, the unnecessary features. So reducing unnecessary features means just delete them, drop them. Df dot drop columns equals to this. Let's drop them. Why we need dimensionality reduction techniques? Why do we need dimensionality reduction techniques? If some features are irrelevant, let's drop them, na? And in feature engineering, what do? We do this only, na? In feature engineering techniques, What do? We actually reduce those features that are not relevant. Attendance link you will get in second half. Okay. Makamana, Hitesh, I think. Okay. Reduce the number of features to improve speed, accuracy, and efficient of machine learning models. Reducing the features is okay. But to reduce the features if they are not relevant, let's drop them, na? Right? I hope you're getting. If some features are irrelevant, why do we need dimensional reduction techniques? Let's drop them. Without without features, dimensions, the model has nothing to learn from. We need dimensions because they describe the data. Without features, dimensions, uh, the model has nothing to learn from. But it doesn't answer my question, Viren. Preventing overfitting. Okay. Let me retell you the question. Tell you the question one more time. It's okay. My question is, my question is, most of the people you have already, explained me really clearly that why do we need dimensionality reduction? You said there are some irrelevant features. There are some. If you have any other answer, please tell me. I'm looking into the chat. You told me that there are some irrelevant features, some irrelevant features, dimensions, whatever. Okay. So we don't want to put those features to our model. Unnecessary, it will increase the, like it will be a noise, right? It will understand like some outliers, something that is irrelevant and all. So let's drop that feature. You know EDA, right? You know DF dot drop, right? You know it. Then why we need dimensionality reduction? Manan is saying to reduce computational overhead. Somewhere it is correct. Yes. Okay, so let's right now understand this. Viren is saying the model becomes faster, simpler, and easier to understand while keeping the important information. Yes, Viren, this can be the answer. Model interpret fast. Okay, what is the issue with what is the issue is with the dropping the features? I want this answer. Nobody's giving me this answer. Why dropping the feature is not recommended and hence we are moving toward dimensionality reduction? Why dropping the feature is not recommended and hence we are studying this dimensionality reduction techniques. We are not simply dropping the features. Why? Why we are not simply dropping the features? Why do we need dimensionality reduction? Reduce the number of input features while keeping important information. Yes, exactly, Ayush. Now I got the exactly answer. Exact answer. Ha, Sujal. Yes, compressing. Yes. Okay, so Parth is saying by dropping feature, but those features which are not going to use in analyzing the data. Prashant, you need to reframe your answer. It's almost there, but some points, some words are here and there. Chalo, Basudev, dropping can create the data loss. Yes, absolutely. But if it is irrelevant, then what is the harm in, let's drop it if it is irrelevant. Information loss. Model interpret fast boost accuracy and performance. Hmm. So now I got really nice answer from 2 3 people. It's good. And one is from Ayush. Okay, it's good, Ayush. Uh Parth, you also good. Sujar, also good. Good one. Okay. Prashant is also okay. So this is actually the correct answer. Like, see, the issue is, simple issue is, if I'm getting 90% accuracy with 50 features, guys, understand the question. If I can get the 90% accuracy with 50 features, and if I can get the 87% accuracy with 10 features, then I can compromise 3% accuracy, but it will actually save my huge cost, huge computational power, right? It will actually will save my so many resources, right? You are just dropping the accuracy by 3% or 2%, but the number of features are decreasing significantly. So what is harm in that, right? And this is the base of dimensionality reduction. There is no harm in those 50 features. We have already reduced all the irrelevant features in the feature engineering. We have already reduced all the irrelevant features in the feature engineering. That is completely gone. But again, we are reducing the dimensions because if we are getting it is if my work is done 87% with 10 people, and if my work is done with if my work accuracy or the parameter is 90% with 50 people, then why would I need more 40 people more? I can just work with 10 people and get the 80% accuracy. Even even to get the 90% accuracy, let's try some different methods. I do have a hyperparameter tunings, right? Let's try. Let's try them. If my target is 90% only, then let's try other methods. Na? This is the base of damage. There is no harm in those 50 features. They are all good. All important features or relevant features. But if I can get that all those things in these 10 people, then why would I need those 40 people more? Simple. Lay off. Let's lay off those 40 people. Okay. And people used to ask, sir, why, in AI, there are so many layoffs. Because of AI, there are so many layoffs. The foundation of AI is layoff. Right? We are laying off so many dimensions. Okay. So, thank you guys, all of you. This was the first half. And in the second half, we'll study something, somewhere like this dimensional reduction in deep and some other things as well. You didn't answer why not dropping those features instead of dimensionality reduction. I answered. I answered. Like even you answered it, in a better way. Damage. If you will drop the features, if you see, okay, let me make it very clear. If those features are irrelevant, we will automatically drop it in feature engineering. Feature engineering, we do it right after data preparation. First, we gather the data, we do some ED and all, we prepare the data, and then we do feature engineering, data wrangling, if you do remember. There only we remove all those irrelevant stuff, everything. Okay? Or irrelevant stuff. Okay? And after training also, there are some, like we look into the those features when, those methods when we'll study about the supervised learning. But but we most of the features we remove it at the time of feature engineering only. Okay. So dropping those features after feature engineering doesn't make sense because those features are important. That's why we cannot drop them. Dropping is never recommended. You have to answer so many questions before dropping a single column, guys. Right? So this is the scenario. Okay? So this is why dropping is not recommended after feature engineering, because in feature engineering you have so many important reasons to show that yes, this is why reason why I'm dropping this, is the reason why I'm deleting these rows, because it is costing us in this way. This is the reason. But after feature engineering, at the time of training the model and all these dimensionality reduction techniques, why do we need this? Because uh, like if I can get the things done with 10 people, then why would I need 50 people? Simple. if I can get that, if I can train my model 87%, 88% with 10 features, then why would I need 40 features more? Let's reduce the features. But we are not simply dropping it, because if we will drop them, then this 87 will, then this 90 will drastically down with to 70 or 65. We cannot afford that. It will be a huge data loss. So this is the reason why we study dimensionality reduction, and in next half we'll understand how dimensionality reduction techniques works. Done. Okay, guys. So uh, I'm stopping the screen sharing. Okay. Thank you so much, and let's meet once again right after 53 minutes. Okay, everyone.
Recording stopped.
Yeah. Thank you, Prashant. Yeah, very much interactive. Thank you so much. As software engineers, how should we prepare ourselves to stay relevant in the AI-driven industry? Study, continuous study. Okay? No other way. Study. Understand mathematics, learn mathematics, deep dive into mathematics. Okay? Deep dive into computer science. No other option. Study. Okay? Is that cloud good? Which cloud? Teeth. Okay? So, uh, Adarsh sir, are you there? Which cloud, teeth? Next lecture. Okay, guys. So, lecture is not ended. You have to attend from 1 to 3. Okay. See you guys in 1 to 3. Okay. Take care then. Thank you so much. The topic better. Yeah. Thank you, Viren. Thank you, Raj. Chalo. See you guys. See you. You are coming, right? You're coming at 1. Don't go. Yes. Yeah. Thank you. Thank you, everyone. Take care. Bye bye.